its distribution. Okay, interpreting z-scores. When the z-score is positive, it means that the data value is greater than the mean. So any z-score that comes out positive means that it falls on the right side of the mean, the data value is greater than the mean. If the z-score is 0, it means that the data value is equal to the mean. And if the z-score is negative, it means it falls on the left-hand side and it's less than the mean. Okay, detecting outliers. Z equals 0 is right in the center. That's where the mean is. So a data value that is equal to the mean has a z-score of 0. Positive z-scores will be on the right, so positive 1, 2, 3. Anything more than that can be considered an outlier. And negative z-scores on the left, negative 1, negative 2, negative 3. And anything more than that, or less than that basically, would be considered an outlier. A z-score can be used to identify an outlier since the further away a data value is from a z-score of 0, the more likely the data value is an outlier. According to the empirical rule, any data value within a distribution, approximately bell-shaped distribution, having a z-score less than -3 or greater than +3 can be considered an outlier, since such a data value is considered an extreme data value. Okay, so if average IQ score is right in the center, and you have an IQ score like Einstein that's way up here, it would be considered an outlier. If average golf scores are in the center, and you're this amazing golf player, and with golf scores, the lower the score, the better. So your golf score is way down here. That would be considered an outlier. Okay, let's look at a baseball z-score example. Determine which league leader had the best average relative to the league he plays in. So looking at this table, we have the league batting average for the American League and the National League. So these two values right here represent league batting averages. We have the standard deviation, 0.03 to 0.05, 0.03 and 0.04. And we have the highest individual average. So by league leader, we mean the best player in that league had an average of 0.347 in the American League, and a national average was 0.362, the league leader. So both of them, obviously, you take a look at 0.347 relative to the mean for the league, 0.247, it's greater. Okay, so clearly it's a positive z-score. And the National League, 0.262 for the mean and 0.362 for the data value is clearly greater, and therefore also a positive z-score. But if we want to know who scored furthest away from the mean, would it be the American player or the national player? We have to calculate the z-score and look at the two numbers. The greater z-score would be the player with the best average relative to the league he plays in. Okay, so using the z-score formula, x minus mu over sigma. X is considered 0.347. This is the individual average, the single person's data average. The league batting average, 0.247, is the mean. And the league standard deviation is sigma, 0.03. So plugging that in, we have 0.347 minus 0.247 over 0.03. Okay, so on your calculator, remember to wrap the numerator in parentheses, and you'll get a z-score of 3.33, which is greater than 3 standard deviations away from the mean, which makes it an outlier. We could do the same thing for the National League player. Another calculation. we're going to take 0.362, the highest individual average, minus 0.262 divided by 0.04. That gives us 2.5. A z-score of 2.5 is also greater than the mean, but not as great as 3.33. And therefore, the z-score for the American League player was higher than that of the National League player. Therefore, the American League player had the best average relative to the league he plays in. Okay, so the American League player with the z-score of 3.33 the data value lies further to the right than the z-score 2.5, and so the American League player had the best average relative to the league he plays in. Greater z-scores when dealing with baseball would be considered more advantageous. When dealing with golf scores, you want smaller z-scores because golf scores, the smaller the better. Okay, now we can also note that since 3.33 is more than 3 standard deviations away from the mean, the American player's z-score is an outlier. And so the American player with his score of 0.347 is an outlier. Okay, that concludes the chapter 3.2 to 3.4. We have one more section in chapter 3, or one